Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here that we are going to discuss today it is the perchloric acid, which is the class of oxyacids of halogens. And if you already know about the halogens, these are the basically group 7A elements that contain 7 electrons in their valence shell, as well as they require just plus one more electron to complete their octet. So that's why they have their oxidation state -1. But due to some other reasons, they have their oxidation state from this to +7. So this is the mainly increase in their oxidation state. And from the class of the oxyacids, here we have the perchloric acid, which is an important class of the oxyacids of the halogen. Basically, perchloric acid here, its formula is HClO4, in which the four oxygen atoms are attached to it, and this is commonly obtained in its aqueous solution. On the other hand, when we have the pure anhydrous compounds, they can only be prepared with the help of one method, which is known as the distilled mixture. And from this distilled mixture, we can be able to prepare the perchloric acid. So let's have a look at what is the main method for the preparation of the perchloric acid. Here, this is the method for its preparation. Perchloric acid is commonly obtained by the aqueous solution. The aqueous solution means the solution that is present in water or the solution in which the solvent is water. That solution is known as the aqueous solution. And here we have pure anhydrous compound. Anhydrous. The word hydrous here is mean the water and an mean there is no water. So it can be prepared by distilling a mixture of potassium perchlorate. Here we have the salt of that is perchlorate KClO4 and by the use of the concentrated H2SO4 which is named as sulfuric acid. Under reduced pressure, when we decrease the pressure and we just heat that solution which is the perchlorate or potassium perchlorate by combining with the concentrated H2SO4, it forms here KHSO4 along with the production of the main acid that we required which is HClO4. Its name is simple perchloric acid. So this is the simple perchloric acid that we obtained over there. Now what are the main properties of these perchloric acids? Let's have a look on its properties. It is mainly having the four basic properties. The first one is it is a colorless liquid. It means it has no color. Then it is hygroscopic acid. And the word hygroscopic is simple means the substances that can retain the moisture or that can absorb the moisture from air. So the perchloric acids can be used to measure the moisture or humidity level in the air because they can absorb the moisture from the substance or from the air. The third one property is its freezing point is -112 degrees Celsius. So that is very high freezing point, like we can say -112. On the other hand, if we just compare it with the water, the freezing point of water is 0 degrees Celsius. On the other hand, it's -112. This is too much high freezing point. On the other hand, when we just look on its boiling point, it is just 90 degrees Celsius, that is less than water. Because the boiling point of water, it is 100 degrees Celsius. So this is a simple comparison between the properties of the perchloric acid and water. So it just started to decompose when the temperature reaches 90 degrees Celsius. So after this we have the some properties which are called as the chemical properties or the reactions of the perchloric acids. So the perchloric acids have the different types of the reaction in which the first one reaction is the simple reaction or its formation, or we can say that it's simple, it's decomposition. We have the hydrogen ions and we have the chlorate ions. Its name is chlorate ion. When they do react, they are changes into the perchloric acids. This is the simple oxyacids. On the other hand, when it is again heated, it produces the two radicals. The first one is hydrogen radical and the second one is chlorate radical. Here, this dot just shows that it is a simple radical that contain an unpaired electron. On the other hand, if we just remove the water from here and there is an addition of the radical, then what does happen? There is a formation of the another radical which is ClO3. And again, if we uses the perchloric acid over there, it changes into HClO3 and ClO4 radical. Basically, this is the formation of the radicals. And then when we uses this HClO3, it produces again perchloric acid HClO4 with the production of the water and with the production of the chlorine dioxide, which is ClO2. So this was the simple reactions of the perchloric acids. On the other hand, if we have pure perchloric acids, it just started to decompose explosively when it is heated. So this is an explosive reaction. So that is why it must be stored and it must be used as 67% solution in water. So this is the main point how we can be able to use that perchloric acids, because the perchloric acids can also react with a lot of organic substances violently. So we must keep them safe. On the other hand, due to its highly oxidizing effect, it is highly oxidizing agent and it is highly acidic, and its acidic strength is also too much high as compared to the other acids, and its solubility of salts. Its salts are also soluble. It is just considered as the valuable analytical reagent. Now here the word analytical means any substance that is used to analyze something or any other substance, it is called as the analytical reagent. So this was a simple topic that we have discussed today. I hope you guys understand, and if you have any queries, you may ask me about that in a comment section and I will get back to you guys soon. The next topic that we will discuss, it is the bleaching powder in detail. For that time, you guys keep learning and have a good day.